Let's finish up our lesson on web scraping, part 1. We are going to take a look at how we can extract data by qualifying by the class of an element. And this adds a level of specificity to the selection of a tag by adding a value of a particular class attribute, sometimes called a selector. And there is more than one way to do this, and we'll see two ways. And if we look at the web page, I know we've been doing this quite a bit, we can find a tag and a class name that uniquely identifies some data that we want. And we're going to focus on something that I've already looked at, and it's called recipe content card. So here I am searching the code for a class that I saw called recipe content card, and this is part of a tag called article. So there are many articles on the page, but not all of them are categorized as a recipe content card. Some of them are actually articles and don't contain any recipe. So for the sake of this example, let's assume that we want only data having to do with recipes. We might be interested in perhaps just the list of ingredients. Perhaps we want to build an API or a database from that data, and this is one way to do it. So if we reference those two pieces of information inside of a find all function, we can get back an object that looks a lot like what we just saw on the page, the entire element. And we can do this and then use the length function to see how many elements on the page fit this description. There is an underscore here, and I want to point that out. The reason that's there is because in Python, class is an important keyword. It's how objects are created. You can define a class that has properties and methods. We don't get into that so much, but it is a really common keyword in Python. So fortunately, the BeautifulSoup library is built to understand the class with an underscore, and it will read that just as class, and it will identify on our page, inside of our results page object that we built using requests and BeautifulSoup. It will identify the tag and the class name, even with this underscore. So let's just run this and see what we get back. I'm not printing the results, I'm just printing how many there are. Let's just print the results to see. Okay, so what we get back is a list. That's what we saw with find all. So every article with the class name recipe content card is returned. It's quite a bit of content. We can also use this method, and this method references the same object that we created with requests and BeautifulSoup, and we use instead the .find function. We reference two arguments, the article argument, the name of the tag, but this time we're using a dictionary to specify the class and recipe content card. So let's just take a look at that. So we really do get the same thing, except notice that it's not a list. It is actually a string. And that's because we've just gotten the first occurrence of that. Finally, we're going to add a really useful function and we're going to chain it on to this this block of code here, and that is the get text function, and that's going to give us content that is marked up on the page. So if I take a look at the article tag with the recipe content card, I should be able to get back some text. Here's some text. It's in between the tags, the opening tag and closing tag. Here's some text: bacon, lettuce, apple pie. And here's some more text. So let's see on the other end of this what we get with our request. Yep, it looks like we're getting a lot of the same. We're getting the same text here. Okay, so that's how we can use the BeautifulSoup library to pull the actual content of a web page, the text. And this last piece here has to do with, it's sort of a modification of what we just did, but we're adding a bit more to it. So let's just break it down. I'm going to reference in the value of an attribute, and we're going to be doing a very common task, which is where we get all of the links on a page. So we start with the recipe tag. We're setting up a recipe tag using our same old object that we created from the page. Results page.find, article is the tag, class is recipe content card, just like we just did. And then from that, so notice that I'm referencing the recipe tag. From that, I'm creating an object called recipe link that retrieves the a tag from within the recipe tag object that I just created. And we are going to print that, and we'll just take a look at what it looks like, recipe link. From within the recipe link object, I want to retrieve the value of the href attribute. So that gets me an address, but it's actually just a portion of an address that could be added on to the epicurious.com URL to form a complete URL. And what that's going to be is a URL that links to I'm assuming the recipe that corresponds to this recipe content card. And we'll run this and see what we get. So first we have printed the a tag, that's this line right here. So this whole object is the a tag, and we're seeing within it, it does have this attribute, which is the link to that first recipe that we see show up when we searched. And from that, we are extracting, just from this a tag object, we are just extracting the URL, but remember, this is just a portion of the URL. And we would have to do a little bit more to create a full URL, but that's not too hard to do. And we're going to be doing that next class when we build functions to sort of automate the process of scraping a page of results like we have in Epicurious, and then navigating to other pages that contain data. So really this page that showed up with all the apple pie related articles is just a starting point. So we're going to need to build a function to start here and navigate into these articles and grab some data, ingredients and preparation data. So we'll see that next time.